The production of sound. In the school laboratory, you will find a small and very useful device called a tuning fork. It contains a stem that you hold with your hand and two free beams which are called prongs or tines. If you were to take this instrument and strike it on a soft surface, you will hear a characteristic humming sound. It is a very simple way of producing sound, and you will observe that these tines or prongs are rapidly vibrating back and forth. You can observe the membrane of the speaker in the sound system in your house. When it is producing a sound, you can actually see that speaker vibrating back and forth. Thus, all sound phenomena ultimately originate from the vibration of matter. What is vibration? Vibration is a rapid to and fro motion of matter. It is also known as oscillation. When an object vibrates back and forth in the air medium, it is causing variations in the density and the pressure of the air around it. These variations in density and pressure then travel through the medium, transferring the energy to the adjacent molecules again and again until the sound reaches its destination. It is important to understand that no air or medium particle is physically moving from the origin of sound to the destination, but each particle is handing over its energy to the next particle and so on. As the vibrating object moves back and forth, it alternately compresses the air medium and then rarefracts the air medium. What does this mean? When the tine of this tuning fork moves forward, it is pushing the air molecules together. As they come together, the pressure of the air is increasing and the density of the molecules, how closely they are packed, is also increasing. These molecules are then transferring their momentum to other molecules adjacent to them. So we observe that this compression is actually traveling through the medium from the origin of sound to the destination. And when this process happens again and again, we see alternate regions of compression characterized by high pressure and high density, and regions of rarefaction where the molecules are spread apart. So these are regions of low pressure and low density. It is the progression of these compressions and rarefactions, one after the other, again and again, which produce the experience of sound. Propagation of sound. As we already discussed, sound is the vibration of matter. Without matter, without a physical medium, sound simply cannot propagate because there is no material, no atoms, no molecules which can transfer the energy of the sound wave further. A very simple experiment shows us why this is so. Take a bell jar containing space for a vacuum pump. Place a bell inside it. If you activate this bell, you notice that you can hear the sound and you can clearly see the bell vibrating. Now, if you gradually remove the air from this bell jar, you will notice that bell is still vibrating as strongly as ever, but the sound seems to be becoming fainter and fainter. If you remove all the air from this bell jar, you will notice you cannot hear anything at all, even though the bell is still clearly vibrating. It is still clearly moving. The reason for this is, as we keep removing the air from the vacuum, the pressure of air inside the bell jar is decreasing. The amount of molecules present inside the bell jar is decreasing. As there is no physical medium between you and that bell to propagate the sound coming from the bell, we slowly stop hearing the sound of the bell. Sound requires a medium to travel. It can be a gas, it can be a liquid, it can be a solid. But sound will not propagate without a medium. Sound will not travel in a vacuum.